Hi, Victor. Hold on. You're muted.
Okay.
There we go.
I think it should be. Hello, Ben.
How
Nice
you
to
doing?
see you. Yeah. It's been a great conference, the Lunar Development Conference.
Yeah, that came off pretty good.
Uh-huh. Very good.
I was getting a little worried. You're the first person to show up. I was wondering if I was going to be here all alone.
Yeah, I was kind of catching up from work, but still also I'll be kind of limited. But I didn't want to miss an opportunity like this. So
Yeah, I appreciate it. Yeah. Hopefully you can correct me on what I get wrong during my presentation. So
okay.
question and answer afterwards.
Very good. Very good.
So I'm sure you know a lot more about the Lunar Regolith than I do.
Well, just a little bit. But I've been learning. There's more people.
Hey. Hi, Nicholas. Oh, looks like he's still connecting.
Yeah. Nicholas. Yeah.
How you doing, Nicholas? Oh, you got you're on mute. See if I can.
Sorry about that.
Yeah, no problem. Technology, right?
Yep.
Oh, there's Evan. All right, so at least we'll have some people. Hi, Irving.
Hello.
How you doing?
Good. How are you?
Oh, not bad. Can't complain. Well, I have to say we now have a better turnout than I had anticipated. So
Really?
we'll call it a success.
Okay, good.
Let's give everyone 5 more minutes and then we'll get rolling.
Okay. I just had a meeting or party earlier today. I'm on the new board of directors for the Space Renaissance International organization.
Oh, cool. So what are you guys working on there?
Well, we just had a 5-day conference the end of June that I'd been working on for a number of months with them. So it's kind of time to reload.
Oh, I hear you. We're going to give it till like after our annual meeting next month, and then we'll start working on the next conference.
When is that?
The annual meeting's August 11th, I believe. Well, I can actually tell you. I've got it here. I'm going to talk about it. Yep, August 11th.
Do we submit abstracts or something? Or?
Oh, no. The annual meeting is more of kind of a state of the society. Michael Mealing, the president, is going to talk about what we did this past year, what we're thinking about, or what we're working on for the next year, that kind of thing. It's just a way to let all the members know that we're actually getting stuff done and not just sitting around. Plus, it's actually required by law, I think, for nonprofit corporation in Texas where we're incorporated. So
okay.
But everybody's welcome to join if you join in if you're a member and just hear what's going on. I don't think there's much more than just the president talking, and then maybe there's some housekeeping, and that's about it. And then and then after that we'll start. I think we're going to start thinking about LDC 2022. Kind of want to get a jump on it. We left it a little late for getting a lot of the stuff done this year, so want to get it done a little early. All right.
Isn't the
Stanley,
Lunar Development Conference coming up next week?
what's that?
Hey, how are you?
Isn't the Lunar Development Conference next week?
Nope, it was last week.
Was last week. Okay.
Yeah.
What am I thinking of then?
We, for internal reasons, we decided to move it up to the 9th and the 10th, but I think going forward, we're going to shift it back to the 20th where we had it last year. You know, centered around the Apollo 11 landing.
Right. I guess I had it written down on the 19th and 20th.
Yeah, I think 19th and 20th
Yeah.
was last year's, yep.
So there's nothing coming up on the 19th and 20th.
Not with us, nope.
Okay.
Hi, Susan.
I know her.
Hello, Ben. How you doing?
Great.
Hello, Irving again.
Hello.
It's great meeting everyone.
Yeah.
I don't believe we've ever met.
No, I believe we haven't, Evan. Maybe we should do some introduction, Ben. What do you think?
Oh, okay.
Sure. We got a minute before we're officially starting. And if you just want to say your name and maybe why you're here or what you're interested in with lunar development.
Caravalis. I'm a postdoc in materials engineering from the University of Texas, and I have a consulting group as well as my own research in the area of, well, all things material science regarding space, lunar, Mars. And my PhD dissertation was developing a technique to extract oxygen from lunar and Martian regoliths. At the same time, you're removing the carbon dioxide simultaneously. So,
Oh, cool. Anybody else want to give a little brief introduction of themselves before we get started?
Well, okay, I'll go. I'm Stanley Max. I teach college algebra at Towson University, and I'm very much in favor of lunar exploration and lunar colonization. And I wish the United States would get started with it. I guess China's going to get started with it, but even that will be a few years. But that's what we should be devoting our attention to, I believe. So that's it.
Yep.
This is Victor Tenorio. I'm a professor of practice from the University of Arizona. I teach at the Mining and Geological Engineering Department. Some of the core courses like Introduction to Mining, Mine Valuation, Underground Mine Design. And I am also leading the first team of undergraduate students, the Wildcat Moon Miners, for presenting in any competition or project design that we can have about moon mining or perhaps later asteroid mining and Mars. So we're trying to cover all that basically from the miner's standpoint and develop a mine planning on our own.
Cool.
Niklas Järvstråt. I'm a structural engineer and scientist. I was active in moon colonization 10-15 years ago and was trying to purchase an iron mine in order to do a precursor project. Been doing other things for a while and want to get back into the moon again.
Sure. All right.
I'm a retired software engineer. Also involved with global risk reduction group, trying to identify threats to existential threats.
Hey, Irving,
Yes, sir.
your audio's cutting in and out.
I'm sorry.
That's okay. Just we were losing some of what you were saying.
Okay.
Every other
Might not
word.
have lost much. I'm involved with Mensa, Global Risk Reduction Group. So risk management is where my background is. And then I'm also involved with Space Renaissance International.
Cool.
Space Renaissance International.
Yes, sir.
Interesting. So you're a Renaissance
everyone.
engineer. Go ahead. I'm sorry.
It's okay. I'm very quick. Yeah, I'm Dr. Susan Jewell. I'm actually a space medicine precision scientist, an entrepreneur in exponential technology. Also the CEO and president of MMARS, which is Mars Moon Astronautics Academy and Research Science, building the first Martian lunar settlement here in the Mojave Desert. And also the CEO and co-founder of Avatar Medic. And we're part of the Anna X Prize, $10 million, building the first humanoid avatar telerobotic surgeon. And very, very involved in deploying analog mission training to austere environments. Much more, but that's it.
Does anybody else want to introduce themselves?
So I'm Dallas Beanhoff, founder of Cislunar Space Development Company. We are defining and hopefully developing a reusable transportation architecture from Earth orbit to the moon and all points in between.
Cool.
I just want to add, I was today formally nominated as the vice president for the Space Renaissance International and heading their SRI's Academy and analog training too.
I'd like to talk to you. Yeah.
Well, we definitely will have time to chat and stuff after the presentation and the Q&A. We've got time to do like a workshop. We need to talk about what we're going to workshop, stuff like that. Anybody else want to introduce themselves? If not, I'll get rolling with the meeting. Okay. Let me get my screen up. All right. So welcome to the first Mare Cognitum virtual chapter meeting. I'm Ben Smith, and I'm the leader for this chapter. If you have any questions, suggestions, or concerns, just let me know. I'm also presenting tonight as the owner of Lunar Homestead. And unless you want to see me talk every month, we're going to need people to commit to present at these meetings. We may have somebody lined up for next month, and I definitely have somebody lined up for November, and that is it. So, you know, go to the website. You can find the webpage for Mare Cognitum. There's the calendar, and you can see all the open dates. So just email me if you want to do it, and let me know, what you plan to talk about, and I'll put you in. I'm hoping that the presentations for this are more educational. Like you're going to learn something new, or you're going to learn some new facet of lunar development or settlement. So that's kind of what we're going for with this. All right. So here's what I got so far. So this is the first one. Mistakes will be made and things will be refined as we go. So we're going to start off with some Moon Society news. We'll talk about some volunteer opportunities, do my presentation. We can talk about my presentation. Some of you know way more about the subject than I do probably, so you can tell me what I went wrong with the presentation. And then we're scheduling time for like a workshop because we figure that it's a chapter and chapters should work on projects. So we need to figure out like what kind of project could this chapter work on that would help move the dial. I don't know what that is. We can talk about that. And if you got any questions, whatever, you can contact me at this address. All right, so here's the news we got. We are currently holding our annual elections, and you're all members, so I encourage you all to vote. We've got several officer positions, vice president, treasurer. We've got 3 board seats up for running, and for the first time in a while, it is a contested election with the board of directors. We have 4 applicants and 3 seats, so your vote does count. I think James said that he was sending out ballots weekly to new members, but if you didn't get a ballot, you know, email me or contact James Burke. We'll figure it out. We'll get it to you. I think we can, everybody can vote up until like the day of, like August 11th is when we're having our annual meeting. So I imagine up to the 10th of August, which segues me into, we're also holding our annual meeting in Slack on August 11th. I don't know the exact time, so you might want to wait till we send out the email that says exactly all the details. Michael Mealing, our president, is going to talk about what the society's done this year, what next year is going to look like. I don't know if anybody caught that during the conference, but we are trying to decide what the society needs to be doing. We figure everything is changing. We need to redirect the society, you know, come up with a good plan for what we can do to help make lunar settlement a reality. And, and we just concluded our latest lunar development conference. Some of you were there, some of you spoke. It was great. We've had a lot of good feedback. If you missed it or you missed some of the presentations, James right now is working on getting those on our YouTube channel. It's a manual process, so give him some time. I don't know how long it's going to take him. I imagine a couple of weeks, but it'll all be there. And then, like I was saying earlier, we're going to probably start working on planning the next one sometime at the end of August after the annual meeting. We'll give it a little time to decompress and do a debrief on it and everything. And finally, Inara Tabir is going to be taking over as the membership coordinator. Now, I've been doing that for 3 years now, and it's time for me to work on something else, like this chapter. Like everybody in the society, I'm a volunteer, and everybody's got limited time. So I'll also be taking the treasurer position if I get elected, and that's also going to take up a lot of my volunteer time. So Nara has a lot of experience dealing with membership, and I'm sure she'll do a great job. So for the next couple of weeks, we're in transition. If you have membership questions, you can just send them to me and I'll take care of them. But by the annual meeting, we're hoping to have her fully onboarded. All right, some of you remember the slide from the LDC when I did my presentation. We are run completely by volunteers. I know we make it look easy, but it actually takes a lot of effort, and we have a very small team. So we have a lot of open positions that we need to fill. We have projects that need leaders, and we just need people with new ideas, energy, and motivation. It's your Moon Society, and we need your help to run it. So here's a list of stuff we need volunteers on. It's not comprehensive, but it's close. And you can find more information on the website. I want to highlight the Mare Cognitum team. Right now, this is a one-man show putting this together, and that's fine. However, we could do a lot more with it if I got some reliable volunteers to help out. I don't even know what that more is, but we can figure that out as a team.
What does the publications coordinator do?
That can be defined by the person who wants to do it. The Moon Society has had a lot of publications in its past, and we had Moon Miner Manifesto. That was 30 plus years until Peter Koch decided he'd had enough. And we tried picking it up, but we don't have somebody willing to take that on full time. We've got presentation papers we want to put out. We've got all kinds of stuff. So if anybody's interested in publications, we've also got Lunar City Press, which has 3 books now that we've got out from our publishing arm. We've got Peter Koch's Moon, I'll have to look it up. Pioneers on the Moon, one for Mars, and then we've got the conference proceedings from last year. So publication coordinator can help coordinate volunteers when we get them to help edit these things, stuff like that. So
that's something I can vaguely help with. Yeah.
Because right now it's all ad hoc.
The other stuff, Lunar PD team, Moon Miner, I know nothing about this. But publications,
Well,
That's
I mean,
a
a lot of
familiar
this
word.
stuff, a lot of this stuff would fall under like the publications, like the Moon Miner Manifesto team. That was our newsletter. You know, the Lunarpedia, that's our wiki for all things Luna. So we need people to help, you know, write articles, curate, find links. It's basically a wiki. So we need people for that, for art and everything. But all of these have more description on the website, at least a sentence or two about what it is. And of course, just contact me or Anara and we can help set you up if you just have questions or want to do something. All right, let's see. All right, that's it. So unless anybody has any questions, I'll get into my presentation. The topic is Lunar Regolith Bad, Mega-regolith Good. I know it's not a great title, but it's what I got for now. And it's basically going to be, I'm going to talk about why I think the Lunar Regolith is a bad place to be and a bad material to work with, and why the Mega-regolith is what we really should be focusing on. So let me switch hats, take off my Moon Society hat and put on my Lunar Homestead hat, and then bring up the screen. Okay, so like I said, I'm Ben Smith, and in addition to volunteering with the Moon Society, I also own Lunar Homestead, and I'm researching the appropriate frontier enabling technology that lunar settlers are going to need to thrive. So let's get into it and talk about regolith. Almost all of the past, current, and future ideas about lunar development and settlement involve using the regolith in some way. Mining it, using it as radiation shielding, playing in it. Besides being easily accessible, I really don't get the fascination with the stuff. As far as I can tell with my research, the lunar regolith has significantly more drawbacks than advantages, and that's what I'm going to talk about today. But first, let's briefly go over what lunar regolith is. All right, so the word regolith is a combination of the Greek words regos, which means blanket, and lithos, which means rock. So it's a blanket of rocks, which is actually a pretty good description of what it is. I think regolith isn't soil. The really fine dust is sometimes called soil, especially in older documents, but I think that's just confusing. I mean, on Earth, soil implies an organic component, which the moon obviously lacks. So in my book, we have regolith and regolith dust on the lunar surface, and soil is what we use in our habitats to grow stuff. How the regolith is formed is one of the primary reasons why it's such a difficult substance to deal with. Regolith formation and evolution is a complex process driven by two completely random mechanisms: the destruction of material caused by impactors and the creation of new material because of the heat generated by these impactors. Basically, impactors hit the surface at high velocity. This shatters the rocks and sends them flying everywhere. The heat from the impact also melts the rocks and glass, fusing them together. The next impactor blows some of these rocks apart and fuses other, and it goes over and over and over again. And the more kinetic energy the impactor has, the deeper it penetrates, and the more material it breaks, fuses, and shatters. The smaller impactors happen much more frequently, so the top layer of regolith gets churned much more often than the deeper layers, and that's why the fine dust is mostly on the surface. Now imagine all of this happening all over the moon for the last 4 billion years. The result is a chaotic mix of layers of boulders, broken rocks, and dust. The first problem with the lunar regolith is that it's located on the surface, and the lunar surface is a really difficult place to operate in. First, there's a lack of atmosphere. I mean, actually, Luna does have a very tenuous atmosphere. It's about 14 orders of magnitude less than Earth's, and for most purposes, it's effectively a vacuum. And in addition to being fatal to life and hard on equipment, vacuum also makes lunar regolith behave in ways we still don't understand. How regolith is formed, plus the vacuum, and the other factors of its natural environment means there isn't anything like lunar regolith on Earth. and it's impossible to fully simulate it. We won't really know how to deal with this stuff until we've actually spent time dealing with it. And while we're at it, let's also factor in all the other fun stuff that the vacuum can cause. Accidental vacuum welding, lubricants that sublimate, organic material off-gassing, and difficulty with heat rejection are just a few. The lunar surface is constantly exposed to high levels of radiation. Interestingly enough, the Chinese Chang'e 4 mission was the first to actually collect data on the lunar surface radiation environment. They measured both galactic cosmic radiation and neutral particle radiation coming off the lunar soil. The result was an average dose equivalent of 1,369 microsieverts per day, which is 2.6 times higher than the radiation environment inside the International Space Station. This level of radiation is about 200 times higher than what we experience on the Earth's surface, and about 5 to 10 times higher than what you'll get on a flight from New York to Frankfurt. This data doesn't take into account the occasional solar particle events caused by flares and coronal mass ejections. These can quickly increase radiation dosages by orders of magnitude on the lunar surface. Designing ways to protect humans and equipment from radiation on the surface can be quite challenging. Maybe we shouldn't spend as much time there. Without an atmosphere, the lunar surface experiences severe thermal extremes. The Apollo 15 site registered temperatures ranging from negative 181 degrees Celsius to 101 degrees Celsius. That's a 282 degrees temperature shift every lunar day, or 507 degrees Fahrenheit for those of us still getting used to metric. This is a problem for both people and equipment working on the surface. Temperature cycling and thermal gradients caused by partial shading can fatigue metal and damage equipment. And the lunar surface is defined by impact events, from large impact basins to fine regolith dust. In fact, that's what's created the dust. A 1 gram impactor will form a crater approximately 3 centimeters deep in lunar rocks. The damage will be even worse if the target, such as a mining robot or a habitat, has been structurally compromised by thermal cycling. And facilities and equipment can expect hits by 1 milligram impactors on a yearly basis. That's a not insignificant amount of energy, considering that these objects will be moving at around 20 kilometers per second on average. Eventually, some piece of important equipment is going to get hard enough to stop working. As you can see, just being on the lunar surface introduces a lot of challenges regarding the regolith. Moving on to the physical and chemical properties of lunar regolith. First, it's really abrasive. The dust, which I'll cover next, is abrasive as well, but the larger regolith particles are still abrasive. I mean, nothing on the moon has experienced weathering by wind or water. Everything is sharp edges, from dust to pebbles to boulders. And all this sharp abrasive rock is going to introduce significant wear on anything operating on the regolith, including mining equipment and spacesuits. Next, the regolith displays wide physical and chemical variations. Here's a quote from the Lunar Sourcebook, which is one of my primary reference materials. Regolith whose structure, stratigraphy, and history may vary widely, even between locations only a few meters apart. I would also add chemical composition to that list based on the Apollo samples we have. You just never really know what you're going to get with each sample. And this is a problem because you kind of need to know what you're feeding into your resource extraction equipment. And most machines don't like it when that raw material has significant variation. Any energy savings gained by using the pre-crushed regolith will be mostly negated by all the crushing and sorting we'll have to do to use the regolith. All of this makes designing regolith processing equipment quite challenging. And finally, the regolith is a relatively thin layer. The median depth of the Mare regolith is about 4 meters. The highlands are deeper, up to 20 meters because they are older, and the Mare are shallower, clocking it at around 2 to 10 meters because they are younger and have had less time to form. Although the Chang'e 3 ground penetrating radar found some Mare regolith to be up to 20 meters deep, and the Chang'e 4 rover data found the highland regolith could be up to 40 meters or more thickened areas. But even 40 meters isn't very deep. And regolith mining operations will quickly scrape down to the Mega-regolith, and then what? Stop? The regolith is a limited resource, and mining operations will exhaust their local supply and either move to a new area or start mining the mega-regolith. Plus, large-scale removal of the regolith will visibly change how the moon looks. First, it will be the astronomers and scientists complaining. Then it'll be the general public. Strip mining isn't popular on Earth, and it won't be popular when anybody can see it by looking up. Oh, the lunar regolith dust. Where to begin? Apollo 17 Commander Gene Cernan said in a technical debriefing, "I think dust is probably one of our greatest inhibitors to a nominal operation on the moon. I think we can overcome other physiological or physical or mechanical problems except the dust." And I agree with him. Now look at the guy, and he's covered in dust and he looks miserable. In my opinion, lunar regolith dust is one of the 2 deal breakers for permanent human habitation on the moon. The other is the big unknown on how 1/6 Earth gravity will affect reproduction. But that's a topic for another meeting. The problems with lunar regolith dust can fill a book, so I'm just going to hit the highlights here. Because it is formed by high velocity impacts and never weathered by an atmosphere or water, it's sharp and abrasive, like powdered glass. In fact, a large part of the dust is made up of agglutinates, which are glass. I wanted to find a picture of an Apollo spacesuit glove to show you how badly the dust damaged it after just a few days, but I couldn't find one. I know it's out there somewhere, but my Google foo was not up to the task. Worst is the dust is extremely small. Think of fine flour. This image actually shows a large dust particle between 400 and 500 microns, but the median particle size is between 40 and 130 microns with an average particle size of 70 microns. That's finer than the human eye can resolve. And worse, 10 to 20% of the dust by weight is finer than 20 microns. This small size means the dust gets into everything. Joints, bearings, fabrics, lungs, you name it. And because it's so abrasive, it quickly tears up everything it touches. To make matters worse, lunar regolith dust is also highly electrostatic. So in addition to getting into everything, it also aggressively clings to most surfaces, which increases the amount of damage it can cause. There's even a phenomenon where the dust levitates off the lunar surface as the terminator moves across the land. The terminator is the line between the sunlight and darkness. So any site will have to prepare for a cloud of dust every 14 days as the terminator passes by. It could degrade solar collectors or just make a mess of areas that were clean just a few days ago. We don't know how bad this actually is at this point, but that is kind of the point. Everything is still just an unknown that we'll have to prepare for and eventually deal with. Okay, so the dust is pretty bad. What else can it do? Well, we found that it can seriously overheat equipment, spacesuits, and astronauts because it absorbs solar thermal radiation, and it's highly chemically reactive, making it toxic to humans. Plus, breathing it on a daily basis will probably cause chronic respiratory problems as the abrasive microscopic particles accumulate in the lungs. Think silicosis, but worse. This image is what the CDC calls a simple silicosis. The lung on the left is healthy, the one on the right is not. The more advanced cases are even more graphic. We haven't seen a case caused by lunar regolith dust yet, but I imagine it won't be a simple case. The kicker is that we still don't really know much about the regolith dust, and we really don't know much about its long-term effects. And we have some ideas on how we can mitigate the dust threat on the surface, but none have been field tested. We just don't know for sure how we're going to deal with this problem. And pushing large amounts of regolith around is sure to make the dust problem worse. Of course, we don't have any experience with this either, so we don't know how bad it'll get. All right, on to the mega-regolith. First, we should probably give this feature a different name. Mega-regolith just doesn't sound very sexy. I don't have any suggestions for that, but maybe some of you guys do. Second, it's called mega-regolith because it's formed by the same process as the regolith, but the impact events and particle sizes are much larger. Large impactors punching through the regolith and blasting out chunks of the mega-regolith of the bedrock beneath. All right, so here's a crude picture I made in paint. The mega-regolith is thought to consist of solid blocks of bedrock ejected from these ancient impacts. Over time, the top layer of the mega-regolith has been impact gardened to form the regolith we see today. We think that the space between these large blocks is filled with smaller rocks, particles, and probably some dust, although nowhere near as much dust as the surface, especially in the Mare. Third, we know almost nothing about the Mega-regolith. None of the Apollo core samples reached into it. We've got some limited seismic data from Apollo. We got some remote sensing and a lot of educated guesses, which is okay because honestly, our knowledge of the regolith isn't that much more advanced either. So they're both kind of starting from jump. Just means we got to go back and really start exploring. So this is a diagram showing what we think is the senologic structure of the moon. Note the location of the regolith and the Mega-regolith. So why should we focus on the Mega-regolith? One of the best things about the Mega-regolith is that it's under the regolith. Being underground removes all of the surface hazards. Let's assume we start mining and building our habitats 10 meters below the regolith. In reality, some sites may require going deeper to get below it, but I'm using 10 for this. 10 meters of rock shielding is enough to stop all GCR, solar event, and neutron particle radiation. No need to worry about career limits or building storm shelters. No need to harden equipment against radiation. Life is good underground. 10 meters of rock shielding completely eliminates lunar daily temperature fluctuations. Heck, 30 centimeters of regolith should do the trick. Of course, we don't know what the ambient temperature of the Mega-regolith is at 10 meters, but it's got to be better than anything on the surface. And throwing a couple of meters of regolith on top of a habitat will probably take care of the small impactors. However, I did a rough calculation and it would take a 430 kilogram impactor moving at an average impact velocity to punch through 10 meters of shielding. This would be a pretty rare occurrence. Adding an extra 8 meters of shielding may not be necessary until it is. And vacuum might not be a problem as well. There's no direct evidence of direct connections between the Mega-regolith through the regolith to the surface. And there could be some anecdotal evidence that there isn't. See, the moon shakes quite often. We think that's one of the reasons for the compaction of the regolith. The in situ relative density of regolith is over 90%, which is very dense, below 30 centimeters. This is more than what heavy compaction equipment can achieve on Earth, which is only 65 to 75%. I mean, the Apollo astronauts had a hard time driving equipment into the regolith. And we don't have any direct measurements of permeability and diffusivity for the lunar regolith. So the high compaction should help with this also. So there's a good chance that any crevices or fissures or cracks have already been filled in by compacted regolith particles, effectively sealing the Mega-regolith off from vacuum. Of course, we don't have any hard evidence for this yet either. The Mega-regolith has two properties that make it more desirable than the regolith. However, I'm not gonna lie, we really don't know how abrasive the Mega-regolith is. I mean, it's still made up of broken rock, so I imagine a lot of it is pretty sharp. But since it's not on the surface, it most likely won't behave as badly as the regolith does. But the Mega-regolith does win on is chemical consistency. Remember I mentioned that the regolith is a chaotic mix of materials and you never really know what you're going to get even within the same site? The Mega-regolith has a lot less of that, especially the deeper you go. The key is that the Mega-regolith consists mostly of large blocks of bedrock material that's been ejected. So instead of getting a surprise grab bag of minerals, we'll get solid blocks of pyroxene, anorthosite, ilmenite, other minerals, depending on where you're located. So in the Mare, that would be large blocks of basalt because that's what the bedrock is beneath it. And not like weird lunar basalt either, but stuff that's very similar to the basalt we have on Earth. That means we'll have an easier time designing mining and mineral extraction equipment because we don't have to deal with lots of random variation. And we can run cheap Earth minerals through the process when we're testing it instead of having to make lunar simulants. There's also a lot more Mega-regolith than regolith. Instead of a layer tens of meters thick at best, the Mega-regolith extends several kilometers deep. And for example, the Mare Mega-regolith makes up 17% of the lunar surface. You know, add in several kilometers of that, and that's a lot of basalt we can use. And finally, because it's underground, we can remove a lot of Mega-regolith without it changing how the moon looks. This may not sound like a big deal now, but give it 200 years of expanding human activity. Another great thing about the Mega-regolith is that we think there is much less dust the further down we go. This should be especially true in the Mare Mega-regolith. Most Apollo core samples showed a trend to coarser grained samples with depth. Of course, the deepest physical sample we have only went down about 3 meters. We really don't know what we're getting into until we actually start digging. But it makes sense given what we know about how dust is formed. It takes a long time for exposed regolith to be pounded into a fine powder. Millions of years of micrometeoroid bombardment. And the Mare range from 3.1 to 3.9 billion years old. That makes them the youngest geological feature except for the more recent impact craters. As such, they've had less time to form dust. And there are also a lot less large impact craters in the Mare. This could mean that those surfaces haven't been churned for a long time, leaving the dust on the surface. Again, the reality is we won't know for sure how much dust is in the Mega-regolith until we actually start digging into it. But I think it looks pretty promising given what we currently know. All right, so that's the approximately 20-minute case for why we should be working on ways to avoid the lunar regolith and use the Mega-regolith. I think it's a no-brainer, but feel free to correct me in the Q&A part of the meeting. And here are some sources.
Go ahead.
I'm sorry, I just got a few more. This is some of the sources. This is going to be up on YouTube, so you can review these at your leisure. All right. So you can learn more about Lunar Homestead, Lunar Homestead concept, projects I'm working on at the website, lunarhomestead.com. Feel free to contact me at ben@lunarhomestead.com with questions, ideas, or just tell me I'm wrong. And thanks for watching. Before we start the discussion, just want to again point out that we need future presenters, so let me know if you're interested. All right, let's open the floor up and get some questions, comments, and corrections.
So Ben,
One question, if I could. Did I hear you say that the moon shakes?
Oh yeah.
As in earthquakes?
These Apollo seismic experiments, while they were operating for several years, showed that it shook quite a bit. I mean, on a monthly basis. There's moonquakes, then they get up to a little over 5 on the Richter scale. But the problem is, unlike earthquakes, which last, for at most tens of seconds, some of those moonquakes lasted 10 minutes.
What causes the meteorite impacts?
Partly, if you go to my website, I actually have a page on moonquakes. But from what I remember, there was like 4 reasons, and a lot of it was orbital. Like they happen a lot more when the moon is furthest away in its orbit because of tidal stresses. But it happens because of tidal stresses. It happens because the moon's still cooling, and so it's contracting on the inside. Impacts from the large stuff actually work too. And there was a 4th one, and I don't remember what that is. But the point is that moonquakes are very common.
Okay. Another question. What's the TDL limit for radiation for human exposure? So I can get a comparison of.
Beats me. I think it would really depend on whose numbers you're working off of. I mean, if it's a one-shot mission where you can blow your
ACGIH.
What's that?
ACGIH, American Council of Hygiene, something or other. I don't know. But
I'm sure NASA has its own. I'm sure every space organization has their own career limits or single mission limits. I mean, it really all depends on what the plan is. If you're just going to send somebody out there for 3 months and then they come home and they never go to space again, that's a different radiation risk than somebody out there who's going to plan to live there the rest of their life.
First of all, Ben, that was a very, very nice presentation, very clear.
Oh, thank you.
And I like that. Maybe instead of mega-regolith, maybe like sub-regolith. So, because I can see there's a clear correlation between the size of the regolith and the depth. I didn't know that, but
yeah.
When I heard mega-regolith, I didn't understand what that means. But anyway, so just a thought, instead of calling it mega-regolith, then maybe sub-regolith. Anyway, that's just a thought, but a really fine presentation. I'm very impressed.
Well, thank you. Yeah, actually, I've read a few papers where they actually separate the mega-regolith out into an upper mega-regolith and a lower mega-regolith. The upper is primarily made up of impact ejecta. So the large boulders were thrown out, and that's what defines that. And the lower one, you still got a lot of large blocks, but they were disturbed by the impact, but not ejected. So, but I think, you know, that's kind of like a different animal than the ejecta one. So I kind of say that the large blocks of ejecta are the mega-regolith, and below that is just disturbed bedrock. But
thank you. Thank you for a good presentation, Ben.
thanks, Madhu.
This is Madhu Thangavelu, and thank you for inviting me to
Of course.
the event.
You're welcome every month.
I just posted.
Question about the composition of the lunar core.
Madhu was just talking.
Let me finish this. Ben, I just posted. You know, I was reading you telepathically because I put up a poster for this meeting, and that I would like to share if I have a few minutes,
Sure.
whenever that might be. But please go ahead. You had other questions.
Okay, let's get Irving first, and then you can show us the poster.
Okay.
Yeah, mine's a quick one. Do we know what the lunar core composition is? At one time, there seemed to be quite a bit of debate or controversy about that. Has that been resolved?
Not that I know of. I mean, honestly, we need a lot more seismic experiments to really I mean, NASA did some, but there weren't a lot of them. And honestly, they weren't located all over the moon. They were located at the Apollo sites. And so if we were really serious to figure out like what the core is made out of, we would need to do a lot more seismic experiments, placing them everywhere, far side, everywhere. I think last I read something, the thought is still that there's a very small metal core and it's still cooling. And like I mentioned, that's part of the reason why we still get moonquakes as it contracts. And let me get this quick question here from Daniel. He asks, are there any proposals for actual missions to dig down to the Mega-regolith and study it? Not that I know of. I mean, you got to get through, you know, if you're in the Mare and it's thin, you got to get through at least two meters of regolith before you even start getting into it. And that's a tall order for any of the landers that I've seen.
Okay, so it would not be a low-cost mission or something you could do with CubeSat, obviously.
Does the moon have a magnetic field?
What's that?
Does the moon have a magnetic field if it has an iron core?
No, I think it's a small one. I think there's a small one, but I think it's mostly overridden by local magnetic fields like mascons. You know, around the mascons, there's like a localized magnetic field, and it kind of overrides the really, really weak lunar magnetic field. At least that's what I've read, but I haven't done any much research into that. All right, Madhu, you got your poster. All right. Any
Madhu, you're muted, Madhu. Madhu, you're muted.
Okay, let me go in here.
there we go.
Oh.
Let's see. I'll probably need to give you permission to share. Bear with me. I've never done this before, so I got to figure out. I don't see a command for that. Maybe you can just share. Maybe there's no permission
Let me
needed.
see if I can see it.
Yep.
Are you able to see something?
We see
We
it.
can see the screen, but we can't see the PDF.
How
There you
does
go.
that look?
No, we had it for a second.
Wait it. Any better?
Yep.
Okay. You know, talking about construction methods on the moon, yeah, there's a fancy thinking that 3D printing is the do-it-all, know-it-all method of building. Nothing could be further from the truth. At USC, we did some studying based on the NEAC work that our team did in between 2012 and 2014. I want you to look at that report when you get a chance. It's posted on the NASA website. What we found out is that a great deal of work needs to be done in casting, starting from preparing the slurry or whatever you want to use as a raw material, and not very clear how we can go about doing this in a vacuum. So we tried several compositions for the slurry and ended up with sulfur concrete. That's in the literature, how you could cast materials. But there are timeless ways of building on planet Earth that may be far more useful and quicker and more energy efficient and simpler and easier in the tools we use than 3D printing. So this poster, it is also a paper, you may want to look at it, tells you how we have built great civilizations around the globe for thousands of years using shaping and honing of rocks. Now, when I saw the final slides of that Ben put up, it goes without saying that Ben, I wouldn't even use the term mega-regolith. I just say boulders. The lunar surface terrain is strewn with boulders of all kinds of sorts. If you remember right, Armstrong navigated himself away from boulders to land on Mare Tranquil Atlantis.
Yeah,
So,
there are a lot of surface boulders.
Absolutely, you know, and it's much easier to think of, and we use a technology called dry packing on Earth. If you go down to, many of the European continent, or to UK, or to Ireland, you'll see how people through the ages have built by just stacking stuff together. Not to mention, if you go to South America, Central America, you'll see buildings standing today that are thousands of years old. And that, imagine that in very dynamic weathering conditions. So now this proposal, which I call minimally processed ISRU technology, MPIT, is something that we want to seriously consider. Because the boulders have weathered over a long period of time, and we can use tooling to shape them into a variety of shapes. And now, in the current era, if you go into your kitchen, you'll see granite slabs. They were tooled on site and polished elsewhere, and they're remarkably resilient for anything, including radiation and thermal stresses. So I want you all to think about other ways other than 3D printing to build structures. They are thermally very efficient, take a lot of heat loading, and go through the thermal cycles, the 28-day cycles. And I just wanted to bring this up to your attention. Thank you.
Yeah, I'm all for exploring all the options, because we really aren't going to know what's going to work best until we've tried them. So yeah. I mean, I don't know if anybody caught my Lunar Homestead presentation at LDC, but I'm working on figuring out how to take the basalt Mega-regolith that's in the Mare and extract the iron and turn that into underground iron hulled habitats. So for me, I'm a big fan of going underground. I think it solves a lot of problems.
Absolutely, yeah.
And I'm a big fan of reducing the engineering requirements. So my plan would be to make it so you can make as many habitat hulls as you need and pack everything you can into them. And put it into an atmosphere, and then you don't have to engineer for all the other problems. So
That's and I agree that lava tubes are an interesting place to work on. If I remember, the late Paul Spudis had written extensively about how we might use lava tubes, and he also mentioned that there are such things as shield volcanoes on the moon.
Can you go ahead and kill your screen sharing?
Yes.
Thanks.
So you want to look at these very large volumes, cavities that exist on the moon, not only from Grail data, but from other geological observations. And I think very good idea to be thinking about lunar underground.
Yeah, I mean, the lava tubes are definitely interesting. I can't wait till we can actually get some equipment inside one of them.
Yeah.
Confirm that they actually exist and that what the interior looks like. My biggest concern with the lava tubes for putting habitats in is that all habitats are going to leak. And so you're going to radically change the environment inside that lava tube.
Oh, sure, yeah.
And so it's probably going to require some kind of modification to seal it up, to keep bits of it from breaking off as you add atmosphere and moisture and vibration. And I mean, these things have been stable for a long time, but they've also had a stable environment for a very long time. So that would be
Ben, I wasn't at all thinking about pressurizing a lava tube.
Oh no, not even pressurizing it. If you drop any habitat into it, it's going to leak. Human activity is going to, leak atmosphere. You're going to change the temperature. You're going to change the moisture content inside that lava tube just by having humans in there. So, and over time you'll change the environment, which means the interior of the lava tube will also probably react.
Oh well, I mean, this is talking about long-term establishments, I suppose, but
well, it's just something to think about. I mean, they could be very useful if we just put up like steel netting to keep pieces from breaking off.
Oh, sure. We are very good with stabilizing that. And the other thing about lava tubes is that when you try to access it, skylights seem easy, but they're very treacherous. And we know this because Lunar Cod suffered a disaster just going down a crater when loose material swamped it. So going down a lava tube is not as easy as you think it is. And we know this from our high seas explorers in Hawaii as well.
Yeah, it's
and then you also need some kind of structure to strengthen it, and then you need steel, and then you need to mine the steel, and then you need to follow an iron ore vein, and then you need to get the rock out of the ore vein, and then you have a structure. So why bother with the lava tube?
Well, that's kind of my thing. I mean, I don't think we're going to get lucky enough to find an actual iron vein. I mean, maybe we will. Who knows? I mean, who knows what's beneath the surface?
I'm sure Dallas has something to say on this, but
oh, do you?
He's just nodding his head, but that's good. Anyhow, thank you so much. May I leave now, or did we have other plans, Ben?
Well, we're going to hang out for a while. I mean, I've scheduled, until 6:30. We don't have to stay that long. I just, if everybody still wants to keep talking, that's fine.
Well, I got to run, but thank you so much for hosting this, and I thoroughly enjoyed the Lunar Development Conference. Keep up the good work.
All right.
And last of all, 20th through the 22nd is the NASA space, the Lunar Exploration Forum at NASA Ames. And I will send you the particulars if you don't have it, but we have some posters there. There are 125 posters this time with Greg Schmidt and Mahesh Anand from Open University in the UK. We'll take a look at them. Some very interesting ideas proposed this time.
No, thanks, Peter.
I'll send the copy to Ben, and they require registration. It's free, and it's a very interesting program as well. And many of the NASA HQ people will be there presenting different ideas. Of course, you don't have to believe them, but you can enjoy it. Thank you very much, Ben.
Well, thank you. Have a good day.
Thank you. Bye-bye.
All right. Anybody else have anything they want to talk about or ideas? Or just want to say, you know, what I mentioned, I'm definitely not a mining engineer. I don't pretend to be one, but from what I understand, to get ores, you have to have some kind of
Not easy.
weathering process, right? I mean, you're not going to find the same thing on the moon because there's no water, there's no plate tectonics, there's none of that stuff that normally forms ores. Am I right about that?
I believe so.
You just said that there is vastly varying content even in the soil in the regolith on top. So why wouldn't there be varying content underground?
Well, it's the regolith. Most of the variety comes from the fact that it's been broken and blasted and churned for billions of years. So, you know, if you've got an impact here and it throws material over here, and then an impact over here and it throws the mixed material over there, and that's why it's just so much variation. When you get down, of course, nobody's gone below 3 meters, but you know, we think that it's going to be much more just large blocks of whatever bedrock is underlying that area. So like in the Mares, it's going to be large blocks of basalt, you know, and different flavor. You know, you get some pyroxene, you'll get some ilmenite, you'll get some olivine, you know, other stuff. But we probably won't get like, boom, here's an ore, an ore of iron. It's going to be more like we got to extract the metal out of metal oxides locked in the rocks. So it's going to be a little more difficult than just finding an ore of metal and extracting it, I think, unless we get lucky. I mean, who knows? There could very well be some ores up near like where the glass was found, where we think those are all like fumaroles coming out of, you know, volcanic processes. Maybe there's some ores there. Who knows?
Yes, Ben.
Yep.
Hello. Just to say a couple of words. As a mining engineer. Yeah, it's going to be very uncommon to find on the moon deposits of high concentration of metals or others. I think perhaps like the rare earths would be dispersed in the material, or in other case also the regolith, and even if it's not necessarily in layers, can be treated more or less like we have calcareous, limestone, other types of materials, non-metallic materials, that we are collecting them by the tonnage, because we are going to use them, maybe crush them and use them for 3D printing. And that would be perhaps an important source of material that we could use for that purpose, but not necessarily for the extraction of elements, unless there is a metallurgical processing where you can extract, like by melting or something, you can extract elements like gold or other precious metals or something, if there's any. Yeah, the mining methods have to be different. I was thinking on entering to, you said 10 meters or so, which sounds very, very prudent, and create a sort of room and pillar, like a coal mine, and that would be a good way of being protected. At the same time, entering the rock will be more solid in terms of requirements of support, and we can still extract what it is there. But first on a kind of the perspective of like coal or other materials, non-metallic materials, that you can extract them by the volume and use them as it is, before trying to be more selective and try to extract other precious materials. So
Yeah.
I think
I
we
like
can
the
start like
idea.
that.
I like the idea of going down and creating like vaulted stuff. I think the problem is that you're not going to get material that's structurally sound like that until you go down a lot. Like you probably are going to get past the Mega-regolith, because you've got blocks that then have smaller particles in between them, and I don't think you'll have the structural soundness to actually like carve out something like, I don't know. I mean, we don't know until we get down, start digging down, but yeah. I mean, that would be great. I mean, if it's structurally sound and it doesn't leak atmosphere, that would be awesome.
Yeah. In that case, tunnel boring machines of some sort will be more useful, and you can dig longer, deeper.
Yep.
And
what I'm working on,
like that.
what I'm working on is my shielded pressurized oxygen resource extraction project is basically a shielded tunneling technique. And basically, as you're in the Mega-regolith and you're mining out the basalt, because I'm just worried about basalt at the moment in the mares, as you're mining out the basalt, you're also building your habitat behind the mine face using the iron you've extracted from that basalt. So that's kind of what I'm working on.
Very good.
Yeah. And of course, the whole point of it would be to make this stuff so low tech that your settlers can then use the iron and the other minerals that they're extracting to build more of the equipment, so they can build more habitats and, keep the process going, try to limit the amount of stuff you have to ship from Earth.
Very good.
Yeah.
I have to leave now, but thank you very much for the invitation.
Oh, thank you so much, Victor. Appreciate it.
All right. Bye, everybody.
Bye.
Bye-bye.
Question, has anybody thought about using von Neumann machines that can replicate themselves, so that you don't have to have quite so much human intervention?
I'm sure there's stuff in the literature somewhere. I mean, I'm sure somebody somewhere has thought of it and wrote about it. I haven't seen it, but I'm sure it's there somewhere. If not for lunar application, then I definitely remember reading something about asteroids using von Neumann machines.
I would say
Daniel. Oh, sorry, Daniel's leaving this one. Thanks. Go on.
I would sort of say that we are struggling to make self-sufficient system to be reasonably small, including humans. I think it is more difficult to do it without humans.
Oh, I agree. I think, well, I mean, that's kind of my thing is, we can do a lot of stuff with robots eventually. I mean, engineering for the lunar surface is tough, obviously, but we could get there. But honestly, what's the point? I mean, the point is to have people go, right? Create settlements, expand humanity. I mean, if we can't figure out the human part of the equation, I'm not sure why we would do anything other than just let NASA send robots everywhere and we get some great pictures and data.
Indeed.
Right, I agree.
But humans are difficult to engineer for. So, any other thoughts on anything moon related at this point? And if not, we could talk a few minutes about if anybody has any ideas for what this chapter could do as a project. I know the society as a whole has a couple of big tasks we want to work on coming out of the LDC. We talked about coming up with a why go back to the moon. So we're talking about maybe coming up with a position paper for that. I personally had the idea that maybe instead of one position paper, we have a lot of position papers on the why, because there's a lot of whys. Everybody's got their own why for why we should go back to the moon. So maybe instead of just one monolithic Moon Society position paper, we could have a spectrum of whys, and different people can write them. So that's a thought. The other thing we're working on is we're reevaluating our mission, values, and all that other stuff. And we've got a channel for that in Slack, and you're all welcome to definitely join into that conversation and figure out what the society should be doing and where we should be going. But other than that, I'm open to any ideas, or if you guys just want to chat space, whatever. I've allocated to 6:30, so I'm cool.
Thank you for a very nice presentation, Ben, and I think I'll get some sleep now.
I hear you. Well, we could definitely take it easy, Nicholas.
Right.
We could definitely just wrap it up. I don't have anything else to present or talk about, so if we don't have anything to chat about, I'm cool with just winding it down.
Good, very good. Good presentation, good meeting. Thank you.
Well, thanks. I'll be here next month.
I hope to be also.
Oh, great. Well, I'll see you then, Stanley.
Yeah, at least I got here before you all signed off.
Well, we're gonna post it probably, Monday, Tuesday next week. I got to figure out the technical process, so it might take a few extra days, but it'll be on our YouTube.
Okay, well, it's good to put a face with your name, Ben.
Oh, thanks. Yep. All right, guys. Well, I'm gonna go ahead and close it unless you guys have something else you want to talk about.
Sounds good to me.
All right. Well, thanks everyone for showing up for the first chapter meeting. It was actually
Thank
a bigger
you for
turnout than
doing it.
do it again next month. The website's got a web page for the chapter, and it's got all the dates. Same time. And I'll see you guys next month.
All right.
All right. Take it easy.
Very much.
Bye.